So you guys can see the project essentially has a whole bunch of components to it. I really did try to avoid busy work within this project, okay? So like, for instance, you're going to be doing lots of calculations, but only half as many interpretations, okay? The whole idea is you're just showing me what the different values that we've learned this year are. So it's always going to start with, and almost every question you have is going to start with a question, because I think questioning and posing questions is one of the more important things. And so my question is going to be, how does the time it takes me to bike here differ from the time it takes me to drive here? Now, we know that there is some difference, right? Would you guys all expect it takes a different amount of time one way versus the other?
Maybe.
And so so that's my question. It's not just what is the is it different, but how is it different? Okay? Now, why would I care about this question? So your part A is just coming up with a question you want to investigate. Why would I care about this?
See which one's faster. You don't want to waste time in the morning.
It's not necessarily about what's faster for me, but yeah, maybe. Driving's faster, but I still bike a lot, right? Okay? But to me, the bigger piece is so I can plan when I leave my house. If I know I want to ride my bike that day because I'm feeling it's a beautiful morning and I want the exercise, I might need to leave a little bit earlier than if I drove, right? So part B of this is you need to justify why someone would be interested in this. Now, are you guys all that interested in this? Probably not. I don't have to find your project interesting. You do. So your justification for this part B doesn't have to be something that you're convincing me that it's interesting. You just got to tell me who would find this interesting. Okay, now, it could be, for instance, I'm just going to keep picking on Jeffrey with football because he says he likes football, okay? It could be Jeffrey wants to compare the rushing yards for Notre Dame versus the rushing yards for Ohio State. And he could look at the yards per rush and all that kind of stuff. I don't find that interesting, but Jeffrey, would you find that interesting?
Yeah.
Do you think the coaches want to know how they're doing in terms of rushing?
Yeah.
Sure. Okay, so it can be anything you want topic-wise, and all you have to do is say who would be interested in it. And it doesn't have to be me, okay? All right. Now, the next thing you're going to do, notice that my question compares two different groups of the same thing. The time it takes me to get to school is my variable. The method with which I get there is the two different groups. Is everybody with me? Hence, in like the example with football, Notre Dame versus Ohio State, like using two different groups, both rushing yards. Everybody good? It could be if you work at a coffee house and you're working this weekend and you're like, oh, I want to know, compare the tip amount from people who ordered coffee versus ordered tea. I would anticipate that people who ordered the expensive coffee are going to tip higher than the people who ordered a cup of hot water. Do you guys see what I'm saying? There's all sorts of things you could pick. And as we said from the very beginning, this class will be as interesting as you make it, yeah? Then you're going to go out and you're going to gather the data. So I went out and I gathered the data. And that's where I stopped building my exemplar because the rest of it we're going to do together. Okay? Now, I'm going to ask that you get at least 15 data points from each group. Okay? So this is just sometimes it took me to bike here. Sometimes it took me to drive here. All right. What do you think I should do next?
5 points.
I don't know. What's part D say? Draw a dot plot. Of both of them or one of them?
One.
If I'm trying to assess, do you know how to draw a dot plot? Do I need you to draw 2 dot plots?
No, 1 dot plot would
You don't even need to do that. You need to do a singular dot plot, and I'm not going to care which group you use. Okay? So, I'm going to do the first one. Let's see, the fastest time looks to be 13.25, so we'll do 13 to 18. If your dot plot is not 100% perfect, am I going to get real cranky about it?
Yes. I'm assuming you'll throw hands.
Probably not.
Probably get attention.
They're just saying that as excuses for your amazing dialogue.
Oh, I don't think it's that good. We good? So do you need to draw 2 dot plots?
Nope.
No. Do you need to draw 2 histograms?
No.
Nope. So the next one we're going to do is the histogram. I will have graph paper available for you guys for these. Okay? So for my histogram,
Can we use the same set of information for both of them?
yeah, and I would.
Okay.
So I'm going to go from 13 to 14 to 15 to 16 to 17. So from 13 to 14, there are 3 dots. From 14 to 15, there are 3 dots. From 15 to 16, 2. From 16 to 17, 1. And then 2. You guys feel okay about this? Does this feel like a reasonable set of expectations so far?
Yeah.
All right. Part E is asking for the 5-number summary of each of your distributions. You will not need to calculate these by hand. Okay, you can do these by using your calculator. So what I'm going to do is just put the lists in my calculator.
For the project, will we be handed a paper like this, or will it be like more instructive, like telling us to do the 5-number summary?
You have this written on the front of, everything you need is written on the front of this piece of paper.
Okay, that makes sense.
I was trying to make sense today, at least once. Okay, so I'm going to take a second, put these in my calculator. I don't want to use this calculator. Just use this one. I just don't want to clear the data out of what's in it for AP. So I'm going to use this one. Okay. Sat, edit, and I'm just going to put the first one in L1. Folks, I would highly recommend you consider, as you're gathering your data, never mind, I don't recommend that. I'm thinking through. I don't recommend that. Okay. Now, once you have the data in your calculator, and I just have the first list for now. Do you guys remember how to calculate all this stuff? What do I do?
Stuff.
Well, so I've got the first list in, okay? So now I'm gonna hit stat, and I'm actually gonna arrow over to calc and choose that first option, one variable stats. I have that data in L1, so then I just go down, hit calculate. And for this list, so for the biking, my min equals 15.02. My standard deviation, oh boy, ignore this for now. I need to arrow down to see the 5-number summary. It's all there at the bottom. So my min is 13.25. My Q1 is 13.67. My median, so on and so forth. Everybody good? And then we got to do the same thing for the other list. So you're going to end up typing both groups in your calculator. And I'm going to go ahead and type that second list into my L2. Only so that, because I'll have to use those summary stats again. So 13.25. And you can run those one variable stats again by hitting the stat arrow over to calc. And what you do to change it from L1 to L2, if you guys look above the 2, you see that blue L2. So you just hit second 2. So for driving, your min is 8.5. All right. Questions? Do we know how to use the calculator to get the important information? Okay. What do you think we're going to do after we find our 5-number summary?
Parallel box. What?
Before we do that? Is that what I say to do next?
Oh, no.
What do I say to do next?
Interpret one of the data sets.
Interpret one of the 5-number summaries. I don't care which one you do, okay? And you certainly don't have to do that interpretation more than once. That seems almost punitive. Is that okay? All right, so I'm just going to do the bottom ones because that's where I have room to do it. Okay, so my min being 8.5, we're going to say the fastest time was 8.5 minutes. Whereas 13.67, the longest time, the slowest drive was 13.67 minutes. Does anybody remember, how do I interpret that Q1?
Isn't it the, like, 25% and below is,
Well, 25% of times were 10.3 minutes or fast, or 10.33 minutes. And in this case, because of the context, or faster. Okay, and then this one will be 50% of times were 12.25 minutes or faster. Cool? What's next?
draw a parallel box plot of your groups. It needs to be well labeled and on the same axis.
Okay, I'm going to start a new page for the, no, I'm not, because I'm going to have these numbers here. Parallel box plot. So this time my axis is going all the way from 8 to 18. Guys, why did I make my axis so much longer this time?
Because you have to incorporate both times.
It has to incorporate both groups. So it's got to have the lowest low and the highest high. Okay? So from here, I'll fill in the rest of my axis. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the first thing I would want is that axis having a scale and a label. And since we're drawing two box plots, we're going to have a label for each of them. So biking, I have 13.25 for my min, 13.67 for Q1, 14.67 for the median, 16.33, 17.75. Then we do the same thing for driving. Questions about parallel box plots? Okay, now what?
Find and interpret the mean and standard deviation of one of your groups.
Okay, so for the biking group, since I have that in L1, and in fact, I'm going to go all the way up. Oh, you know what? I'm going to do you guys see how I just did the driving summary stats? I have all of them up there anyway. Okay, so my mean for that is just the X bar. Which part was that part? G or H?
H.
H, okay.
G was the parallel response.
Okay, so my question was, how are they different? Yes?
Yes.
What's the time difference, give or take?
Like a minute or two.
A minute or two? Are we cool with using the median and saying, hey, the median for the driving group is, and to find this, I could even say, I don't know, subtract 12.25 and 14.67. Okay? So I might ask guys, do they have about the same range? Like, do they take, like when I look at this distance and this distance, they're similar. They're not identical, but they're pretty darn similar. But so I'm going to say both graphs.
It seems like the
Part H, my X bar is going to be the 11.58. We interpret that as that equal shares point. So it would be if all the times it took to get to drive to school were the same. They'd each take 11.58 minutes. My standard deviation was the S off my screen, which works out to be, I'm looking at it right now, is 1.57. Okay, so we're going to say on average, drive times vary from the mean by 1.57 minutes. She thinks I'm cranky when I tell her how distracting her laugh is. And I'm like, it really is distracting. You don't get it.
Does she make that laugh when she fails a kid on a test? She just hands the kid the test and just laughs.
There's also like thunder in the background. It's
If there's a teacher in our department that would have that feeling,
Mr. Richards.
Oh.
I've had that feeling once or twice, but only when a kid's been super disrespectful to me and I try to help them and then they ignore me and then I hand them the test. It's happened once, maybe twice since I've been in Grandview.
Who was it?
I'm not going to tell you that.
Was it like recent or was it like?
I'm not going to tell you that.
What was their first name?
I feel like it'd be hard to fail one of your classes since like you're a good teacher and everything.
Wow. Suck up.
It's true.
Oh no, our teacher's just good, man.
I'm sure I had you do one more thing, yeah?
Write
Yeah.
a paragraph that summarizes how the data helps you answer your question. Be sure to include how both the centers and spreads of your distribution compares.
Okay, let's go back to that parallel box plot for a second, y'all. Say the median drive time is 2.42 minutes faster than the median biking time.
How long does the paragraph have to be?
2 or 3 sentences. Doesn't have to be crazy. This is an English class.
Understandable.
Does this fully answer the question? No. Because I also want you to talk about the variability and the predictability. When we look at these
Q1 and Q3 on both graphs are just kind of swapped from each other where the median falls more towards the Q1 on one graph.
kind of, yeah. So I'm going to say both graphs show similar spread. And let's talk about that for a second. Does that make sense?
Yeah.
Why would that make sense?
Because I'm assuming you bike on the road, so you'll hit traffic lights and just regular traffic.
So, but why wouldn't that take longer biking? Since biking takes longer.
You can leave in between them.
Well, it doesn't take shorter either.
Ignore stop signs. Maybe blow through a few stoplights.
So my speed while traveling, like so when you think about why aren't all the drive times the same? So stoplights, all those kinds of things. Guys, I bike and drive the same route.
You have
So
to-
the stoplights, the causes of the like why it's not always the same commute are the same whether I'm riding on my bike or riding. And I don't blow through stoplights on my bike ever. You wanna know why?
I want to eat it.
Cars are bigger than me. And it would hurt to get hit by a car while I was on my bike.
I mean, I did it, I'm fine.
Also, with your bike, like you actually have to pedal to get going, so you have that time to like.
So
actually
does your car.
get going. But it's not as like fast or not as slow. I mean.
Anyway.
Also, hills on bikes. 'Cause-
What? Oh, is there a hill coming
Yeah.
here?
Don't you have to? Don't you live in German Village?
I live in Victorian Village.
Okay, almost same thing, just a bit of difference. But there's the big First Avenue hill.
I don't come up First Avenue, but I do come up Third, and it's all uphill from the Giant Eagle all the way up to the school. It's all uphill. If you guys have ever biked it, it's miserable.
Going down was
You've run it, yeah?
Yeah.
It's awful. I hate it.
Do it every day.